Alrighty, thanks very much. So yeah, I'm Russell Wolf. I'm a multi-platform engineer at TouchLab. I joined TouchLab in this past February after having been doing multi-platform stuff for a little over 2 years. It's actually funny, Greg, you were talking about the like initial release of multi-platform in 2017. So that first release I was concurrent with Kotlin 1.2 was just JVM and JavaScript because Kotlin native was still kind of in early development at that point. And it became possible to do like Kotlin native got like added to multi-platform in February of 2018. And I was looking back at my Git history recently. And I guess I like did my first, like wrote my first code in, like wrote my first Kotlin multi-platform code the day after that release. So I jumped in pretty early. So and that code was not quite yet the library that did, but one of my early projects that I still maintain was the multi-platform settings library. So yeah, that's a few notes about me. But let me get my thing working. Let's talk a little bit about Kotlin. So Carlos gave a pretty good kind of introduction to how Kotlin multi-platform works. So I don't want to repeat those details too much. But as a quick summary, Kotlin multi-platform takes the different platforms of Kotlin and lets you compile platform agnostic code to multiple different targets. So that might be JVM, which is Android, or like server-side Java, JavaScript, which might be browser or might be Node, or native, which might be desktop native, embedded, or iOS. And then you can use platform-specific code to talk to the APIs of those individual platforms. And like we're all very used to the smooth JVM interop that Kotlin has on the Java and the Android side. And you have similar interop with the platform APIs of whichever other platform you're running on from your platform code. And one thing I do want to note there, because I did see a question go by on it from the first talk. So you can do expect actual to talk between your comment and your platform code. And in a lot of cases, it can be nice, and it can do certain things that interfaces can't, like having expect constructors or expect top-level functions. But one of the disadvantages sometimes is expect actual is forced by the compiler to be a one-to-one relationship. So there is exactly one actual declaration per platform for each expect declaration. And one of the disadvantages sometimes of that is you can't swap that out for in your test code. So sometimes it can be nice to still stick to old-fashioned interfaces because it lets you like pass in a test mock instead. And yeah, the other point I want to make is Kotlin multi-platform is very well suited to mobile platforms in particular. So like yes, you can share between any of these different platforms that they provide. But one of the things that's nice about mobile is to your users, like Android and iOS are roughly the same thing. And like, yes, under the hood, they're doing lots of different things, but there's a lot of opportunities to share code between mobile Android and iOS apps because they're probably going to be doing the same thing because your users and like your project managers and such usually want them to be doing the same thing. And I'm not the only one saying this. Like Jeffrey, when the last year's Kotlin Conf launched this like Kotlin for cross-platform mobile development page to signal like their interest also in pushing this use case as like one of the key use cases for multi-platform. And yeah, I really think it is the one of the best ones. but of course, like that's all I have to say. Like, how do you actually like get started with it? So yeah, Carlos gave us a great introduction. But one of the things that you can find if you've been kind of following the space for a while is like Kotlin Multiplatform over the last 2 years has been a bit of a moving target. Like the best practices have evolved, the tooling has changed dramatically from what it was 2 years ago. And it's gotten a lot more stable recently than it was early on in terms of breaking changes and things happening. But there's still a lot of kind of old information out there that can get confusing. And then there's also the confusion of like what libraries exist. So Carlos was also talking in the first talk about like here are some of the kind of libraries that you've used to replace what you're used to on the JVM. And that's also kind of one of the early sticking points that a lot of people starting out have of like, yes, even though my Android code is kind of doing the same thing as it was doing natively, it's still talking to different libraries, and that still is a change that you have to get used to. And then of course there's all this new configuration stuff that you have to learn. So at TouchLab we kind of were thinking about all this stuff and kind of getting feedback about the difficulties that people are having. And that's what led us to put together the sample project called CampKit. And that is both it's a project template as well as a set of documentation so that you can have a source for like what is the kind of up-to-date best practice. And we're committed to keeping that up to date. So one of the challenges that we made with it is once you have kind of the build tools installed, like you have Xcode and Android Studio installed or IntelliJ, it pretty much runs out of the box. And that was important to us because one of the pieces of feedback we were getting was during teams would like set up a hack week and they wanted to investigate Kotlin Multiplatform, and they would spend the entire time just trying to get something running. And that means you have no time to actually like see how it works for a use case, and that would then cause people to dismiss it as not ready, even though if they'd kind of gotten over those source config hurdles, they might have actually been able to make a lot of progress. So we wanted to kind of help teams get over that hurdle more quickly. So here's what the template app looks like. It's a single screen. It's makes a web call to grab a list of dog breeds, and it lets you select which ones are your favorites. And in doing so, it runs through the whole kind of like basic stack that you might see in a typical CRUD app. So you make the web call, you say things to the database, and then you query that database to display the data in the UI. So a couple of notes on the architecture of that. So the data layer is mostly shared. So that's the networking logic, the database logic, the kind of glue that holds everything together, and then kind of like the data that then gets exposed back out to the UI. The UI itself, it's two separate native UIs, and that lets you kind of continue to leverage your like native tooling expertise in kind of doing the top level build of that UI and of like working with the latest APIs that those platforms provide. And one of the kind of common themes in a lot of the decisions that we made in building CampKit was kind of making things play nicely with Kotlin native threading model. So you'll kind of see that as a bit of a theme as I walk through some of the code. So I'm not going to go super deep on the concurrency model. Kevin Gallagher has some great talks on it that I highly encourage you to check out. But the kind of short version of it is Kotlin native is much stricter about mutability and threads than you're used to under JVM. So anything that is mutable can only live in a single thread and can only be accessed by a single thread. Something that's immutable can be shared across multiple threads. And immutable here does not mean val versus var or list versus mutable list or what you might be thinking of from what you're used to on JVM Kotlin. Immutable here means frozen, which is this new API that exists just in Kotlin native. That means that object and everything that it has a reference to can't be changed and will throw a runtime error if it does. What that ensures is that when you pass something across threads, it must be in the exact same state in every thread, and you can't get into these weird race conditions where you might get inconsistencies and hard to debug errors. So those rules are like simple to state. The implications kind of can take a little bit for you to fully kind of like grasp them as you're working with them, and they're a little different than what you're used to on the JVM, but it is very possible to work with them, and it can help you write better, like safer code. In particular, like it plays nice with architecture that kind of focuses on immutable data and kind of like a bit of a more functional style, which is a bit the way that the industry has been going lately anyway. So let's talk a bit about some of the libraries that exist in the KNP space and kind of how we're using them in CatKit. And I'll start with Kotlin X coroutines. So coroutines are Kotlin's asynchrony library that you're probably used to coming from the Android world. There's kind of two major APIs that we make use of in CatKit. There's like using suspend functions where you're just kind of like suspending and waiting for a single value, and there's flows where you're listening to a string of values. And these, of course, so you can use these in your, you can use any of these APIs in your Kotlin code on iOS, but suspend functions don't get exposed to Swift, so you can't use it from like your UI level code on iOS. So the way to work around that is you can kind of manually pass some sort of Lambda callback. And in Kotlin 1.4, there will be a kind of thing that generates that automatically, so that you don't have to set that up manually yourself. Another kind of important piece of what we're doing in CatKit is coroutines in Kotlin native, the release version are single threaded, which in practice often means main threaded, but you can be single threaded on a background thread as well. And that obviously has some limitations. So there's a preview release of multi-threaded coroutines that hasn't been merged into the main trunk yet, because there's some issues that they're still working on in terms of some memory leaks that can happen. But CatKit, which is trying to be like mostly state of the art, but a little bit forward looking, makes use of that multi-threaded branch to kind of get you started writing code with it, in the hopes that like by the time that code hits production, that will all be stable. And another kind of note around our coroutines usage in CatKit, we're expecting to do some refactors at some point in the near future around how we handle coroutine scopes. So like right now, the shared code is creating its own scopes, and we'd like to adjust that so that, at least on the Android side, the Android code can pass in things like the model scope that you get natively in Android. So if you're looking at the code today, like expect some changes there at some point in the future. So moving on from coroutines, the dependency injector that we use in CatKit is Coin. or I should say the dependency manager, so that I don't step into the middle of that like dependency injection versus service locator debate. We're using again, this is a preview of the next version of Coin. It's an alpha of Coin 3.0. And it's what that adds, and this was contributed by Kevin again, is it basically adds some thread safety by kind of enforcing that the configuration of Coin happens on the main thread on iOS, so that you're not accidentally passing some things across threads. And within our usage of it in CampKit, we have kind of a couple different integration points across common and platform code. So you can, within Coin, you can kind of inject dependencies at different levels. So we have the core module, what you see in the middle here, that passes dependencies that kind of only need to be configured from common. We also have a expected platform module, which lets the common code, or let's say lets the platform code pass in kind of platform specific dependencies that Coin needs to have access to. And then we also have this extra app declaration lambda, which lets not just the platform code of the shared library, but also the like top level application pass dependencies in, and that lets us insert the Android's application context into the Coin graph. And then, yeah, one other point I want to make about Coin is there's a test API that they expose, which we have a test in CampKit that demonstrates, called check modules, which provides kind of the same sort of graph checking that you get in something like Dagger at compile time, but it runs at unit test time instead. So if you're concerned about moving from something that's kind of compile time checking your graph to something that's runtime checking it, having something like that in place can still help you kind of feel confident that your graph is staying consistent. So KTOR is the cross-platform HTTP client that JetBrains provides, yeah, so it's a coroutine aware HTTP client. Sorry, I just did the code. That animation went in the wrong order. So it does its JSON conversion via the Kotlin serialization library, which I won't go into more detail on because we don't actually do anything specific with it other than kind of using it as a backbone there. So KTOR right now is not multi-thread safe in that it's built against the release version of coroutines, and doesn't work very well if you kind of call it from different threads. So we have this this workaround kind of buried in CampKit, which is this network lambda that you can see on the right there, and that basically kind of forces the KTOR calls to happen from the main thread, so that KTOR can handle its own threading internally in the way that it's expecting. So hopefully that goes away over time, but it's not stopping you from using this stuff right now if you're configured correctly. SQL Delight, we already heard about it as well earlier today, but it is the cross-platform or multi-platform database library. So what's neat about it compared to something like Room is it generates its models and queries from SQL statements. So what you see on the right here is like the code that you write is just the create table statement, and the like the data class to implement that is then like auto-generated by SQL Delight. So that it's kind of like the inverse of what Room does, where Room you define your entities in your DAO objects, and then you have to like annotate them with SQL that has to match. SQL Delight kind of does the opposite and says like just start from the SQL, and then you'll like you can generate the Kotlin code that's correct without needing to manually match it up yourself. And then it has platform specific runtimes, so you kind of pass a separate I'm forgetting the word they use, but you have a separate engine to it from Android and from iOS that that's actually running the queries. Another thing we have in here is multi-platform settings. So that's my library. So it's key value store. So SQLite is your like complicated structured data storage. Multi-platform settings is your, I just have like one or two little name values, like a timestamp or a user ID or something that I want saved. And also has some update listener APIs, which are not currently used in CampKit. So yeah, I won't say too much about it because despite it being my thing, and you can hear me talk about it in some of my other talks, it doesn't play a huge role on the CampKit side. But yeah, similar to SQLite, you pass in a platform specific delegate that's kind of what's actually driving the backend storage, and that lets you share that backend storage from your shared code and your platform code. Stately is a library from TouchLab that's focused on various parts of concurrency management. So part of what it does is it adds kind of common definitions of the different Kotlin native freeze APIs so that you can call those from common and not just from your native code. In a starter module, it also kind of adds some different threading primitives. So this YAML code on the right is using Stately's guarded stable ref, which essentially like enforces that the reference that it contains is only accessed from a single thread. And that's part of the internals of that network call that we're using to work around KTOR. And then another thing it has that's not currently in CampKit, but is kind of worth discussing is a module called isostate that essentially lets you handle state in a multi-threaded context by kind of having a single thread that your immutable state lives on, and then it provides you APIs to kind of go in and talk to that state while handling the threading for you. So there's a collections or some collections implemented on top of that are much more performant than the kind of older stately collections that were all based on atomics and did a lot of kind of blocking because of that. Last thing I'll go through quickly is Kernit, which is a logging library that we've recently been putting together at TouchLab. And it's the kind of key piece of it is it's immutable after, like your logging configuration is immutable after you first configured it, which then makes it safe to pass between threads. So it's not yet merged into CampKit. There's a PR open right now, so you'll see it there soon. Yeah, we're interested to hear feedback if it is or it isn't hitting your use cases. So that's much libraries. I'll also talk a little bit about just some other notes on configuration. There's a bunch of kind of like new Gradle things that get added when you go from Kotlin JVM to Kotlin Multiplatform. And from like we have them all kind of set up for you initially, but we can talk about kind of what some of it is. So the big thing is like the way that you set up your dependencies changes because you have to specify all your different targets. So within your Kotlin block, or you have a Kotlin block now within which you call these different target functions. So like this Android function or the iOS ARM64, iOS x64, and that tells the build system like these are the platforms that my code is going to build to, and then that will generate main and test source sets for each of those targets, which you could then kind of separately configure dependencies for. A lot of dependencies these days are being published with Gradle metadata, which means you can kind of just set them from your common main, and Gradle will figure out how to kind of put the right platform-specific dependencies in place. But certain things like the standard library, you still have to specify for each platform. Another small note here is there is a helper function called iOS that essentially does what this block here on the right is doing of checking whether your using the simulator or using an actual device on iOS. And it sets an intermediate source set kind of between them. And it doesn't always play nicely with the IDE, especially with Android Studio. So you might see that in some other samples, but we tend to recommend like sticking with the manual configuration for now until the IDE side and the kind of inference side gets cleaned up. Another thing you might be noticing here is we're using Kotlin build scripts. I tend to find like it takes a little bit of getting used to moving from Gradle to Kotlin in your build scripts, but it's really nice kind of having some autocomplete and being able to, especially with the kind of new Gradle APIs that are involved on the multi-platform side, it's nice having some autocomplete to be able to make things a bit more discoverable. And then we have some configuration to opt into generics on the Objective-C side, which in Kotlin 1.3x aren't automatically forwarded to, like, generics in Kotlin are automatically forwarded to Objective-C and Swift in Kotlin 1.3, but it will be in 1.4. And then we opted into the experimental coroutines API because we were using them in a bunch of places. Another thing we have in there on the Gradle side is we have a version of the CocoaPod Gradle plugin. So this is a fork of the official JetBrains plugin. So generally the philosophy around CocoaPods is it uses a bunch of the iOS integration configuration. So without that, you kind of have to manually set up your frameworks and like set up a Gradle task to copy that framework over to Xcode. And there's like 2 different ways that you could do it that were in different samples for a long time. That CocoaPods kind of helps handle that all kind of more seamlessly under the hood. Unfortunately, the JetBrains plugin is not, you can't really configure the framework that it generates. So one of the things that we wanted as we were building up CampKit was the ability to debug things in Xcode. And to do that, you need to have a dynamic framework instead of a static framework, which the default CocoaPods plugin didn't allow for. So what we've added is the ability to kind of specify a frameworks block within the CocoaPods extension so that you can, so that whatever configuration you want to add, you can pass in there. So yeah, we like generally expanded configurability and also some adjustments in how the pod file is generated, which helps deal with some caching issues that can cause you issues when you're like trying to make sure you're getting a clean build. And yeah, that's still in, like, we're still kind of actively developing that and kind of like figuring out what other things we can do to do with it to kind of help the development flow. So let us know if you have use cases. Then a little more on the Xcode side. TuxLab has a debugging plugin for Xcode, so you can debug your Kotlin code. You can debug, like, step into your Kotlin code from the Xcode debugger. And CampKit is set up so that the Kotlin sources are already in the Xcode project, so you can like immediately like jump to the right source. But you do have to like install that plugin yourself on the Xcode side. So I'm a little short on time, but in the time I have remaining, I'll talk a quick bit about a couple kind of things that we've built on top of this. First one is less interesting. So in general, CampKit has been really nice for letting us, like, not just for kind of like showing people like here's the way you can get started quickly, but also for us to kind of prototype things quickly. So one of the ones that I did recently that I want to do a blog post and go into more detail on at some point soon, but I've seen it asked in Slack a couple times lately, is around interop between RxSwift and coroutines. So this is a thing I put together that kind of like roughly does that, where you can, so the generic memory of flow doesn't get exposed to Objective-C because flow is interface and Objective-C generics only work on classes. But if you add a wrapper class around it, you can kind of maintain that type safety and pass it up to the Swift side. And then you can add this extra kind of route durable generic function on the Swift side, which lets you kind of like pass the different callbacks that Flow is looking for, and hook them into the RX Swift observable. So this isn't perfectly thread safe as written if you're doing a bunch of threading things on your RX Swift side, but it's kind of like a start of how to make them talk to each other. And of course, we've also like built some production code with this. So we had a client that was having us kind of like prototype like what does a feature module look like in our existing app, and we were able to use CampKit as kind of the starting point for that configuration. So we had to kind of like make some changes to plug it into the client's build system, and in particular, like their iOS code lived in a different repository than their Android code. So we did a bunch of work around kind of being able to toggle between building the shared framework from source, or just like referencing it as binary. And it's been nice kind of like working with clients and being able to kind of go back and update CampKits with the learnings that we've had from using similar configurations in production. So I think I'm a minute or two over, but a couple of just kind of like quick final thoughts. So like the general nice thing about Kotlin Multiplatform is you have a lot of flexibility. So I've talked a lot about libraries in here and local configuration things, but depending on what you want to share, like if you just have kind of like a pure business logic thing, you don't need to use any of that if you don't want to try out any of that new stuff. Like if you just want to write your Kotlin code, you can do that and share it fairly easily. I also want to definitely emphasize like this, like I'm a huge proponent of this stuff, and I definitely think it's kind of the future of how a lot of us will be building mobile apps, but it's definitely in the early adopter phase now, and you should make sure you're kind of like comfortable buying into that. So like there were some questions earlier around like, is it production ready? And I think what production ready means is different to each team in each organization. So there are teams using it in production now because to them it is production ready. Your opinion of that will vary depending on kind of like your needs. But it's definitely at a phase where it makes a lot of sense to evaluate it and see if it is over that line for you. So yeah, I think with that, I will pass things over to questions.
Nice job. Thanks so much, Russell. Fantastic here. So we're going to get the questions going pretty quick. Before I do that here, I've got to give you the, you know, we're going to stream in our live audience here so that they can. And that was it. Great job. Okay, so I'm going to have Uli bring up our questions here, and his screen should be sharing with us at this point here. So you should see the questions from Slido coming up on your screen. I'm going to pop out for this.
Sure. All right, so at the top we have what is the best CI/CD workflow to share a multi-platform lib inside a mobile team, like single repo or a shared lib. I think that is a thing that will vary by team. Like one of the nice things about kind of the modularity of Kotlin multi-platform is you can kind of continue to lean on the same like build pipelines and stuff that you already are in your native code as you're trying to introduce it. So like the new piece is now you have the shared library that you're going to want to like build and test, and if you're in separate repos, you'll need to kind of like publish the autograph for it. If you're in the same repo, you can kind of test them all at once. I don't know that I can like, yeah, I don't know that I want to point to kind of like a single best workflow. I think you can you can kind of like make that choice depending on what your needs are and on like maybe how much code you're sharing and how much you need to test the library in isolation versus kind of altogether. So do you find it beneficial or detrimental that KMP doesn't include shared UI? I wouldn't say, I certainly don't find it detrimental. I think it's like, KMP is trying to do a different thing than Flutter is. Like Flutter is trying to be shared UI, and maybe kind of like skips over the details of some of the stuff that happens under the hood. KMP is about kind of working at that lower level, sharing things that are kind of like more at the logic layer, and less physically tied to the platform. So I think that means that KMP is a lot more flexible. So like Flutter is going to have a pretty big impact on the architecture and the build process of your whole application if you're using it. KMP you can kind of like slot in wherever you want, and it can be as much or as little as you want, and you're not paying a huge penalty for even if you're just using it a little bit. Any tips on improving build times? Certainly is something that we're doing some thinking about, and it is something that like JetBrains has been improving over time. So like if you tried this stuff like 6 months ago, it definitely does build faster than it did then. Off the top of my head, I don't have kind of like specific tips, but like I mean, modularizing always helps if you're doing something large scale. Like any way that you can kind of not need to rebuild your Kotlin native code will help. How do you get around the Kotlin native closed world principle? How do you get around the Kotlin native closed world principle, e.g. writing iOS UI classes in KMP and using index code or Kotlin subclasses in Objective-C not being exposed properly? So this is basically talking about there's some limitations around in the internet around the fact that you can't kind of go back and forth multiple times between Kotlin and Objective-C, and you like each Kotlin or each binary that you like each framework that you create out of your Kotlin code kind of doesn't know about the others. And the way to get around it is, I mean, the easiest way to get around it, if you can, is to kind of do more things at the Kotlin level. Because like if you're kind of like just in the Kotlin world, then you don't have as much of those limitations. And if you're not able to do that, then it's just about kind of like segregating things such that you don't have too many interdependencies between your modules. So like if you have multiple frameworks, making sure that they do independent enough things that they don't need to talk to the same stuff under the hood, so that you don't have to worry about kind of which version of Kotlin they are in the hood. So hopefully that sort of also answers the next question of what is your experiences with dependencies between two libraries. So it is like it's possible to have multiple Kotlin libraries in your framework as of 1 through 70. We've been doing some kind of testing of some limitations of that, and some blogging about that, I think. But so it's possible to have two. You can't like they won't be aware of you can't really like pass Kotlin types between them. So if they have interdependencies between them, again, you'll want to do that more at the Kotlin layer than at the so at the Objective-C layer. Do I know any framework for Kotlin UI? So there's a couple people that have done like some things. There's nothing that seems to have really caught on very largely in the community. I tend to think it's like it tends to not be my focus, and I tend to think it's a little bit kind of early to be too focused on the UI side of things. Like where Kotlin really shines is more at the logic layer, and you'll have a easier time working with it if you can kind of get into the mindset of, I'm not going to share every piece of code, but I'm going to share the things that make sense to share. What are the pros and cons of different ways of defining dependencies? Mostly it's stylistic. Doing that, I've done both in different projects. One of the slightly annoying things of the by getting style is you get all of these unused references, unused reference warnings, which you don't get in the source that's bracketed version. But ultimately, doesn't really make a big difference. It's doing the same thing under the hood. In order to share code with the backend, any tips about how to import a library written with KMP from a backend written in JS? So I personally haven't done a ton on the JS side. So I have a JS target in multi-platform settings, and I've have a Hello World project that builds a JS browser target. But I haven't. I'm not very familiar with kind of the more the deeper side of JS configuration. So I definitely recommend asking about that stuff on Slack though. And if you haven't looked at JS in a little while, there were some pretty heavy refactors to kind of how it's configured in a while ago now, a year or so ago now in Kotlin 1.3.4d, and the documentation has gotten a lot better on that in the last couple of months. So if you haven't looked closely at it recently, definitely take another look and see if that helps. What is the difference between immutability and freeze? So in the language that I was using when I was talking about freeze, they are the same thing. So when you call freeze on an object, or when an object is frozen, its immutability is it is enforced as being immutable. Probably off topic, what kind of moves is TouchLab making towards desktop app support? None that I have been a part of. Though it's something that we pay some attention to on the library side. It's easy to expose a target to a desktop platform from a library that we're building. We'll do that, but we're the clients that we're talking to are much more on the mobile side. How is the performance of isostate? Any suggestions, best practice to handle the shared cache with good performance? So for that, I'd refer you back to Kevin's blog post where he talks about it. It's much better than what you had with atomics in the first state of the collections. It's not going to be quite as good as what you get with just a single threaded thing. But that's kind of the trade-off that you're making by having state that you want to access from multiple threads. How do you decide which libraries to include in CamKit? Largely by the ones that we want to be using in the apps that we're building, and the ones that kind of work well in the situation that we've encountered, and that we kind of trust to keep updated. When do you decide that this logic part won't be shared? I'm not sure I understand specifically which logic part that is, but in general, you can make that sort of decision and even change it over time. If you're trying to figure out what do and don't you want to share within an existing code base, you can kind of pick an area that seems to make sense to start off and add more to it over time. It's not kind of a permanent thing. Do you know if there's a clean way to share test artifacts between two MVP modules? So the one way that I've done it, and you can see this in multi-platform settings, if you look at the configuration in there, is create a separate module and define those test artifacts in that that module's main code, and then you can depend on that module from your test code. So it takes a bit of configuration, but it's doable.
Well, great, Russell. Looks like we were able to make it through all the questions. Thank you. So, we've got one more that popped in. We'll give you a couple seconds to answer that one as well.
Sure. Yeah. What is the best architecture to use in KMP? Also, what is the best way to maintain check compose states in KMP? So I'd say in general, like KMP is unopinionated on your architecture. Like I tend to find it works a little nicer with like MVVM and MVI stuff than it does with MVP, because you might be kind of moving back and forth between your platform and your shared code, but also even that is not a huge deal. As far as Jetpack Compose stuff, I don't have a great answer for that, other than that, like most of the things that you would probably have at the compose level are going to be at your UI layer, which is probably your platform specific layer. So assuming that is correct, you're just going to kind of leave it in your platform code anyway.
Nice. Well, thanks so much. This has been fantastic to have you, Russell. Also, Carlos, thank you for being with us. Again, this was our first installment of the multi-platform series, so we expect to go deeper. I know there were some questions, differences with respect to Flutter and Kotlin multi-platform, so we'll be covering some of those as well in a future event. So anyway, really have been great to have you all. Thanks for everybody who signed in to this as well. It was great having you here with us. And again, check back regularly at droidcon.com, and you'll be able to see what's coming up next. You'll also be able to get all of the presentations there probably within the next day or so. And we look forward to seeing you again at further series here at droidcon online. Thanks so much again for being with us, and we'll see you next time.